So in this particular lecture, I'm going to show you how to perform a linear regression using KNIME. So as usual, we need to read our data first. And if you have a CSV reader, and I'm going to keep this picture here on the top so we can follow easily, and you can also see the process that we are following. To read a CSV dataset, we can use a CSV reader. If you have an Excel dataset, that you can use an Excel reader like earlier. So simply search here, or if you have the node already available, then you can just drag the CSV reader from there and bring it here. Remember that you need to connect it to the dataset. So right click, configure, then it will show you the path that you can specify right here. Click browse and go to the folder where you have your data. So I have it here. I'm going to bring it to the platform, and if you want to get rid of any column or variable, you can do it here, but we are going to use the column filter later on, so we are going to just keep it there like this. Click apply, click OK. Now you are ready to read. Simply read the data, put a comment here like import CSV data, and we are ready to now proceed to our next step. So as I showed earlier, we can filter our data so we get rid of any null values or missing values, because that's going to be a problem in the future. So we can get rid of that right here. So to do that, we can bring another node that's called missing value filter, right? Similar to this one, you see here, search for missing value, simply drag it here, connect the nodes like this. Now it is available for you. Configure, and remember, these are the three options because we have three different types of data available. We have integers, we have floats, and we have a string. Now you can leave it as it is not going to do anything, but we want to do something, right? We want to get rid of the null values, so we will remove the row that has any null value for any column. If you have a smaller data set, I would suggest to instead let's say replace it with the mean or median or mode, something like that. Based on the data and the analysis that you are doing, you can basically decide what to do. So I'm going to select remove row for this one as well, remove row, and finally this one as well, remove row. So click apply, click OK. Now it is ready. See that the yellow mark here, or the color, it simply means you are ready to roll. Let's run this one. And if you had any missing value available in your data set, this process or this step is going to remove that one from your data. Remove NA. So this is very subjective. You can put any comment that is something that you can remember in the future and see and understand what happened in that particular step. All right, so the next one is you can either do column filter or you can do low variance filter. If you have a larger data set, I would suggest you to go always with the column filter, because of course you are not going to use all the columns or variables, right? So search for column filter and drag it here. Again, connect this to our previous nodes by dragging and drawing a line. Filter unwanted columns. All right, so once we connect it back to our data set, when you click here, you can see that there is a pop-up window here available that shows you all the columns that are included at this moment to your data set, in your data set. If you want to remove any column, let's say I want to remove this one, because this column superhost N and superhost S, both are the same columns. One is in numeric form, one is in string form. Now remember that in case of linear regression, we cannot use a string, so we are going to remove this one and keep the numeric one. So it is going to be used in our model building and for our regression. So I removed that one. It is going to be excluded. Click apply and execute. And now we have these columns available in our data. All right, so what is the next step? Let's get rid of any column that doesn't have any variance. So what it means is, let's say that you have a column where all the values for every single row is the same. So you have someone is a superhost. Let's say the column says superhost, and all the rows are either 1 or 0. That means there is no variance, no difference. So it doesn't really matter in our model, in our regression, because there is no difference there, right? So you can get rid of that column based on the low variance filter. So search for low variance filter, drag it here, connect it, and now go to configure, and you can see that the upper limit is given as 0. Just keep it that way. So it means that if a column has 0 variance, as I mentioned earlier, if it does not have any difference, all the rows are the same data, then it is going to get rid of that column. Keep all the columns that are already here to our consideration for this step. Click apply, click OK, run it. It is going to, of course, get rid of any column. See that this yellow triangular mark here, put your mouse cursor, it is going to show you a statement or a message for you. It says no columns were filtered out. That simply means we did not have any column that had 0 variance. That means we are good, because our columns have some variance and we need that for our regression. So put a comment here. Zero variance. And now we are ready to finally run our regression test. Search for linear regression. Learner, don't use a predictor. You will find a linear regression predictor as well. We don't need that. The predictor is used for building a prediction model. We need the learner. So bring a learner here, connect it to our previous nodes like this. Now click configure. See that it automatically selected by default the very last column in your data set, and it was superhost n. For this linear regression, we don't want a binary. Superhost n is a binary column, and we don't want that. Instead we are going to use the price column. Price is like what someone sets the price for their rental, and this is a real data set. So if you go to Airbnb, you will see that different rentals have different prices. We want to understand what are the factors that determine or affect this price that someone sets for their rental. For example, let's say, let me give you an example. Let's say that I am renting, or I am offering a 2-bedroom, 1-bath apartment, and someone else is offering 2-bedroom, 2-bath, and it's a house. Of course, the rental price is not going to be the same for both rentals, correct? So see that the size or the number of bathrooms, number of bedrooms, number of beds, all those factors are going to determine or affect what's the price is going to be for that particular rental. Another factor can be the ratings that we see when we go to Airbnb, right? So when you go to Airbnb, you see that I have a rating of, let's say, 4, and someone else has a similar house, but they have a rating of 5 out of 5. Of course, you are going to rent the one that has a 5 out of 5 ratings, correct? So all those factors, as I mentioned earlier, are going to affect your nightly price that you are going to set for your rental. So we want to understand which one affect our price, which one affects positively, and the amount or the size of our effect. All right, so we have all these things ready here. If you want to exclude any column from your regression consideration, you can also use here and simply use this back button to put it back to the exclude list, and it is not going to be considered. But for us, we are going to use all of those. So let's just continue like this. Simply make sure that your dependent variable is the correct one. Click apply, click OK. Now we are ready to run the test. All right, now click, go to the third option that says open output port. Go to here, go to the table. All right, now let's take a look at the output. We have the coefficients. These are the effects of different variables or independent variables that we have here on our dependent variable price, right? The nightly price that someone sets for their rental. But what is also important is to look into this p-value. Is this effect significant or not? And you can see if it is greater than 0.05, then it means that the effect is not significant. Remember that if it is greater than 0.05, then it is not significant. So what we can do here is we can sort this based on the p-value, and now you can see that the only factors that are significant based on the 0.95% confidence interval or the p-value of 0.05, right? Less than 0.05 are only these variables. So the rest of the variables are not, based on this particular data set, are not significant, and we can say that the effects are not significant, right? So the significant ones are here, right here, from number 14 below. All right, so you can also, based on the coefficients, you can also sort. So there's a very convenient option that KNIME has. You can sort and you can look into the output from different angles. So these are the one that has the highest effect on your dependent variable. For example, the review score communication, extremely important. You send an email to the host and they don't get back to you. It's not very convenient and people don't like that. So communication score is very important. Then let's use the p-value sorting and accommodate how many people the house can accommodate. So let's say that in my family, if I have 6 people, then of course I'm not going to go to a smaller one. The smaller one that can afford maybe 3 people, of course the price will be less than some other house that can afford 6 people or 10 people. So that is again related to the size of the house. Number of reviews, how many reviews the person has, review score communication, overall review score rating, check-in, and all those things are important. So you have to check both the effect and the p-values to determine which one is significant or not. But for your future predictive model building, we are basically going to use all of those to build our predictive model, and we will see that in the future lecture. All right, I hope this is helpful. Please reach out if you have any questions. Thank you.